Okay, so today we're going to be making a program to play a simple blackjack game. It's going to involve a number of classes that we're going to create, and so I'm going to walk you through that process. You'll notice I haven't set up any files yet because I'm going to do that with you as we go. Okay, so the first thing we're going to do in creating our blackjack game is we're going to create classes for cards and a deck, and because those are sort of necessary in order to be able to run blackjack, and it's a good introduction to show you how objects and classes work. So we'll start with the card class. So let me just add a new class. We're going to call it card. You notice I'm going to unclick the public static void main because our main entry point is not going to be in this class. You can say finish. All right, and we're going to do that. And let me just add another thing. So in order to represent a suit, I'm going to create something called an enum, and I'll explain what that is in a second. Okay, so an enum, you can think of it as basically like an integer, in that it it sort of encodes its values as integers, 0 through whatever. But instead of integers, we can actually, name it other things that are sort of more intuitive. So I'm going to make my enums be the suits, the 4 valid suits of the cards. Okay, and this just allows us to have a type called suit that takes on one of these 4 different values. And you'll see how we use that in the card in a second. Okay, so and actually let me just add a little comment here. Okay, so let's go to our card class. Okay, so our card class, basically, when you think about what defines a card, it's defined by 2 pieces of data. Namely, it has a suit, which we're going to call my suit. And notice here, we're giving it the modifier private to say that this data is only available within the card, within the methods of this card. So someone using this card can't see what my suit is, and you'll see how that works later on. We're also going to declare private data called number, or my number. And this represents basically the value of the card. 2, 3, 4, jack, ace. You'll see how we do that in a little bit. So let me just make some Java.doc comments here. And so we're going to say ace has a value of 1, and the face cards, jack through king, have values 11 through 13. Okay? Now, we have our card here, and so now what we're going to do is we're going to make a constructor. And this basically is the method that's called to create an instance of our class card when we use the new command. So let me do that real quick. So when we call, so this is just a method. We're going to require our user to give it a suit, and we're going to require our user to give it a number. Okay? And all we're going to do is, when we're given this suit and this numbers, we're going to set our suit and number to these values. And notice I'm using the this notation here to access my private data, my suit, and my number. I could actually, I don't need that. I can just do like that. But I personally like to include the this in there because it emphasizes to me, the programmer, that I'm accessing properties of this data of this class card. So I find it helpful, but of course you can do it or not do it. Okay, so let's add a little comment here. And you'll notice again our Java doc populated already based on our parameters here. Okay. Now, so basically this allows us to create an object or an instance of a class card. And again, if you're a little unclear about the differences between classes and objects and instances, you read up on that on the web. The sort of one example that I think I may have mentioned before is you can think of an apple as a class, and it has certain data like taste, color, crunchiness, things like that. And that is sort of a general idea of what an apple is. But then you can have an instance of an apple, which is this particular apple on this table right here that I'm pointing to. That is an instance of a general class called apple. So it'll become more clear once we just use these a little bit. Okay, so one thing, because this number here is private, often we might want the user to be able to use that, and so we're going to create a method called getNumber. All it does is it returns the number of the class of the card. The idea here, by keeping our number private, we could make it public like that, and then we wouldn't need this. But then this would also make it someone else could set the card after we've initially set the card number after we've set it in our constructor, and we don't want that. The general idea is you make as much of your data private as possible, and as many of your methods actually private as possible. You release as little sort of to the outside user as you can, and it keeps things contained nicely. Okay, so we have our getNumber. Another method that's going to be really useful is we want to be able to print out the sort of the name or the string of this card. So normally if we have, let's say my suit is diamonds and my number is 10, we'd want to be able to have this card be able to say that it is the 10 of diamonds. And so what we're going to do is we're actually going to override or overload the toString method that is sort of that comes basically all, without getting into too much specifics, all classes in Java inherit the general object class. And every object class has a toString method. So we're basically going to make a custom toString method for this card right here. Okay. So the number string is the thing that we're going to. So look, let's see what Java says here. Right. So it says this method must return a result of type string. It knows that because we have that string return type right there. So we will do that in a second. What we're going to do is now we need to take our number here, my number, and turn it into something that makes sense, either 2 through 9 or 2 through 10 or ace or jack and king or king. And the way that we're going to do that, we could do that with a big something called an if-else ladder, where we say if the number is 2, then this number string equals 2. If it equals 4, it equals, you get the idea. But what we're going to do instead is use a switch statement, which is a little more elegant and nice for this kind of thing. So we're going to switch on my number. And again, if you're not familiar with the switch statement, just look it up. It's pretty straightforward. Okay, now what we're going to do is when my number is a 2, we're going to say the number string equals 2, like that. And this is just some syntax there. Okay? When the case is 3, okay. I think you get the idea of how this works, so let me just sort of type this out really quick. Okay. Now, I mean, obviously this isn't the only way to sort of implement this kind of numbering. For another way that we could have done this is just made a string array with whose elements are 2, 3, 4 all the way up through ace, and or really ace 2, 3, 4 and on, and with that, and then just index into that array using the number because. And that's a totally sensible way of doing it as well. I just sort of randomly decided to use a switch statement, probably just to show you guys how switch statements work. But as with pretty much any programming problem out there, there are many good ways of doing it. So what we're going to return is our number string plus this plus, now here, check this out. Notice in our suit enum, these are sort of, technically these are integers, but we can use the toString method that's sort of inherited from our suit and this actually gives the proper name here. So what's Java saying here? So it's saying it may not have been initialized because what if it's not, what if the number isn't, and this actually should be a 1 here. Well, so even though we know that's stupid, we're just going to say this. Okay, let's say this is error. Because if numString is still error down here, then we've got a problem. Okay. So I think this will do it for our card class. Again, we've got a suit, we've got a number, we've got a way to construct a new instance of our card class via this constructor here. We have a method to return the number of our card, and we have a toString method which returns the name of the card. All right, so now let's go on to making our deck class. And that's going to be a little more involved, but that's okay. Okay, so first, let's import java.util.random because we want to be able to do some deck shuffling. So let's think about the data. So when I'm making classes, I always start with what's the data that I want my class to hold. So I think what makes sense for our deck is we want it to, and most of that data is almost always private. We want it to have an array of cards. We want it to have a certain number of those cards, right? So when we create this array, we're going to have to say how big do we want the array to be? Do we want it to be 52 cards? Do we want it to be 104? Do we want it to be 156? But as we deal cards, the number in our deck is actually going to decrease, so this number is going to change. The number of array slots won't change, just some of them will become empty, but this number is going to change. It's going to tell us basically how many cards we have left in our deck. And I think actually those are the only two data properties that we need in our class. Let's add some Java.comments comments here. Okay. Now let's make our constructor. Now, there are a couple of things for us to keep in mind as we're making our deck constructor. One of them is that, often in Blackjack, casinos will have more than one deck. Usually when you're just playing with friends, you have one deck, but casinos will often have 4 or 6 or 8 decks. And so we'd like to have that functionality as well. It's not that hard to implement. So let's add in our constructor, in our deck, how many sort of 52 card decks do we want? Secondly, let's add an argument to say whether or not we want the deck to be shuffled after it's created, because playing Blackjack with a non-shuffled deck is pretty useless. Okay, so let's add comments. So, in creating our deck, the first thing we're going to want to do is say this dot. We're going to say since we're going to create our full deck, the number of cards we have in our full deck is the number of decks times 52. Okay, hopefully that makes sense. Actually, let's change that to non-decks. Okay. Secondly, we now need to make our array called myCards, like this. And if you recall, this is how you make arrays. And we're going to initialize it like that. So that means we're creating a new array where each slot or index is an object of type card, and there are num cards total slots. Now, I should note that in this implementation, I'm choosing to represent the cards in my deck as an array of cards. There are at least 2 other very reasonable, if not perhaps even slightly more reasonable ways of doing this. One is to use something called an array list, which would look like this. An array list of type cards, like that. And another would be to use a linked list. I can't remember. I think it takes a type like this, but I can't totally remember, so don't quote me on the syntax. And these are nice. An array list is basically like an array. Sort of under the hood, an array list operates like an array. But it handles a lot of nice things that we're going to have to do. Namely, if you remove things, it shifts. You remove something from an array, it shifts all the values over. You can add things easily. It's really nice, and we'll often use it. And a linked list is a slightly different type of data structure, which we'll come to in a little bit. But these are 2 very good candidates for myCards as well. So you could read up on those a little bit if you wanted, but just for the sake of simplicity, we're going to just stick with just an array of type cards because it's the most transparent way of representing the cards in our deck. Okay, so now what we need to do is create our deck, and what we're going to do this using some nested loops that basically just create all the cards, all the numbers in each suit for all 4 suits for each deck. So I'm just going to do this, and you should see sort of how it works pretty easily. Okay, and so what we're going to do is we're going to add a new card to the deck. So this is my cards. And what we actually need is we need an index, a card index. Okay, that's that C there. And we're going to say that the card index at position C gets a new card, and again we have to pass it a. We go back to our card constructor here. When we create a new card, we have to pass it a suit, and we have to pass it a number. Okay, well, so the suit, we have here our suits are integers, and so what we can do, we can use this syntax here to get at the appropriate enum value. So suit, we're going to say suit.values, which basically just returns an array of the possible values, and we're going to index into it like that. All right, and we're going to give it a number n. And actually, as I'm thinking about it, let's go back to our card constructor. If someone accidentally puts in, -10 or 20, we don't want that. We don't want that to work. So it's very common to do sort of checking of these parameters to make sure that they're valid. So we want to say if a number is greater than or equal to 1 and a number is less than or equal to 13. That basically just ensures that we have a valid number. Otherwise, we're going to say system.error. We're going to print a standard error. We say is not a valid card number. Okay. If we were more sophisticated, we might throw in something called an exception here, but we're not going to worry about it. We're just going to print a standard error. We're going to exit with status 1. We basically exits the program, and the status 1 tells whatever program calls our Blackjack program that there was an error. Okay. I'm just going to close that just to keep things clean. All right, so we've added our new card, and of course, we also need to increment our card index so the next time we come to this statement, this C is 1 more than it was before. Okay, so now that we have basically created our cards here, we need to now optionally shuffle our deck. So, shuffle if necessary. So if shuffle. Now notice I don't say if shuffle. I could say if shuffle equals true, like that. But since shuffle itself is Boolean, we can just say if the value of shuffle is true. Then we're going to go to this dot shuffle, and Java's going to complain because it's going to say, hey, you don't have a shuffle method yet. Well, we're going to make one right now. Okay, so this is that's the end of our constructor. And actually, before we make the shuffle method, let's just add one other constructor, something called a no args constructor, or no arguments constructor. Whoops. Right? And this is just going to sort of define the default behavior if we don't pass, if we don't pass anything in. So what we're going to do is we're going to call the other constructor defining one deck without shuffling. So notice what we've done is something called overloading. We've overloaded this deck method depending on the number of parameters and the type of the parameters that go into the deck. So now we have our two constructors, and just to save space, let's collapse those. Nice thing about an IDE, you can do that. Okay, so now for our shuffle method. So here we're going to use our random number generator. Let me actually just make the comment real quick. And the way we're going to shuffle is just, there are a number of different ways you can think of. And so one way that's pretty simple and intuitive is just randomly swap pairs of cards in our array. If we do this enough times, we're going to get a shuffled deck. But in order to do that, we need our random number generator. Okay, and when we're doing a swap, when you're doing any swap of two things, it's very useful if you have a temporary sort of variable to hold one of the variables while you swap the other one into it. Okay, so we're going to create a sort of temporary index called j. I'm going to say while I is 0 and I is less than this.numCards. Okay. What we're going to do is we're going to, get a random card to swap I's value with. That random card is going to be J. So we're going to use the random number generator next int method, and this n here is our upper bound exclusive. So what that means is that this is going to generate values between 0 and numCards minus 1 inclusive. So if numCards is 52, this will generate values between 0 and 51 uniformly over that space. And that's what we want because that's the range of the valid indices. Okay? And so now we're just going to do the swap. So we're going to store the value of at I, the card value at I, into temp. Now we're going to say my cards at j, my cards at I equals my cards at j. So we're storing j's value in I. And now this is why it's useful to have our temporary values. So because we want the value at j, we normally, if we just said this, if we said my cards dot, j, my cards j equals my cards I, that wouldn't work because we just in the line before we set the value at I equal to j. So that would be just j equals j, which doesn't do anything. That's why we need this temp, because we store the value of I so that it's not lost when we, update the value at I with j. Hopefully that makes sense. Okay, so we basically do this swapping for every card, and the deck at the end of that should be reasonably shuffled. I'm sure there are people who would argue that there's a sort of more formal, better way to do the shuffling, but this is good enough for us now. Okay, so let's minimize that. Notice that that the method names that aren't constructors begin with a lowercase, and again, like in our card, they begin with lowercase, and then the second word is an uppercase. This is sometimes called camel case. Okay, so the next thing we need to be able to do with our deck is to deal a card from the top of the deck. Basically, what we're going to make a function called deal next card, and it's going to return the card on the top of the deck. Excuse me, a method, not a function. Okay. So we're going to get the top card. All right, and that's just the card in position 0. And we're going to return it like that. Okay, so let's make our Javadoc comment. Okay, so this would seem fine, but this isn't enough, right? Because as soon as we deal the card, we need to remove it from the deck, and that doesn't happen in just this code right here. And what that means is that we actually need to shift all of the cards that come after this top card up one, basically to the left one spot in our array. Now, the array list, if you remember up here, I was saying that, oh, we could use an array list or maybe even a linked list. In an array list, even though under the hood it's operating on like an array, it has built-in methods to do this kind of shifting itself. So we wouldn't have to code it like we're going to do just now. And if this were a linked list, because the data is organized slightly differently, it's not organized in an array, it actually is very easy to use a linked list. It's almost trivial actually to remove the card from the top. And if I were going to do this again, and if I weren't doing this for instructional purposes, I would probably use a linked list. But again, we'll get to linked lists in a little bit. They're a little more complicated than just straight up arrays, so that's why we're not using them right now. Okay, and this is good just to sort of see what needs to be done. So now what we need to do is shift all the subsequent cards to the left by 1 index. So all we're going to say is C minus 1, right? So when C starts at 1, that means if C is 1 here, this becomes 0. Just like that. Now, of course, at the end, when C equals num cards, this loop is going to exit. We want to sort of zero out. If we don't do anything after this, we're going to have two cards in the last two indices. The cards in the last two spots are going to be the same. So we need to sort of empty out that card in the last slot, like that. And we're going to do that by setting equal to null, which when you're dealing with objects is sort of the equivalent of empty, or there's nothing there. Okay, and of course we also need to decrement the number of cards in our deck. And then we should be good. Okay, there's one other method that's going to be useful, mostly just as a sort of debugging step that we'll use next to sort of check to make sure that everything up until this point has worked. But we want to just be able to print out the deck. And we're going to give a parameter num to print. All right, and this is just going to say how many of the top decks. We're not removing the cards from the deck, and actually we're going to make this method of type void, which means returns nothing. Right? We're not going to remove them from the deck. We're just going to print them out. So we're going to start this at the top of the deck. Like that. We're going to loop through the first num to print cards, and we're just going to print them out. Now I'm going to use a method called printf instead of our normal print line, just to sort of show you something new. It's incredibly powerful, and there are printf implementations. I think it started in C, but maybe even earlier in Fortran. But pretty much any modern computer language, programming language, has a printf method or function. And what it allows you to do is you give it a string, but you can give it formatting guidelines, and I'll show you what I mean here in a second. Okay, so what all these percents mean? So what this means is this says, okay, print a number, an integer, which is, we tell it it's an integer by the letter D here. So print an integer that whose total width has a width of 3, and whatever isn't taken up by the just digits of the number is padded to the left with spaces. Okay, this just says print an integer. And this is a space, and this says print a string. And then this is print a new line. Okay, and these args, we need to basically give it 3 values, 2 integers, and then a string. What those values are is the first one's going to be C plus 1, basically card 1, card 2, card 3, card 4. This is just handy. The second one is going to be the number of cards. And the third one is going to be our toString for that particular card. All right? Again, we could have done this by adding together, integers and num cards and this, but in many ways, sometimes it gets messy and pretty cumbersome pretty quickly if you have a lot of variables that are sort of going into the string. And using this string formatting capability that's available through printf is pretty handy, and I recommend getting comfortable with it. Okay, and we're also going to print and this is totally stylistically. We're going to add a couple tabs in there, and we're going to say we have this many others, right? So we're going to print out the first num to print cards, and then we're going to say, oh, we have this dot num cards minus num to print. We have this many other cards that we're not printing. Okay? So let's test this. So what we're going to do next is let's make another class, and I'm going to call it game runner. Right? So this is the thing that's going to have our public static void main in it. All right. Delete that for now. We'll populate that later. Now, this isn't the real code that's going to go in here, but let's just create some code to test our card and our deck classes so far. So we're going to say deck, my deck equals new deck. And remember that our deck takes a number of decks and it takes shuffle. So we're going to say 1, and we're going to, let's first not shuffle it. And again, this is basically, so let's actually just give the no args. All right, and then we're going to go my deck dot print deck, right? And you'll see notice here how the Eclipse is populating our Java doc, right? This is why you do a Java doc, is so that this little helpful thing can be populated, this helpful little text here. Okay, so we're going to print the deck. Let's print the first 10. Okay, very simple. This is just sort of checking to make sure things work. And actually, I'm lying. Let's print the first 24 so we can see a full 2 suits. Okay? All right, so we see that the first card is Ace of Clubs, 2 of Clubs, all the way down to the King of Clubs. That makes sense. And then we get diamonds. Ace of Diamonds all the way down to the Jack of Diamonds. And here we see 28 others, and I'm just going to go in and do a little syntax change. Let's do that. Make it just 1 tab. All right, so that seems to be working pretty nicely. What happens if we make it 1 deck, but now we make it shuffled? Right here, you see that there are, that the cards are randomly ordered now. All right, so it looks like everything up until this point is working. That's great. Now what we need to do is make, the way that, this is the way that I've chosen to implement it. We're going to make a class, one more class called player, that is going to represent either both the human player and the dealer, or the sort of machine player. So our players all have names. They're sort of faux real people. Right? And the player also has, what's the other information relevant to the player? Well, the player has a hand of cards, and as well as the number of cards in the hand. So the way that we're going to make our hand is just going to be, it's going to be an array, and array of cards, just like our deck is. The thing is, though, is we need to know how many sort of slots to make available in our hand, and we don't technically know how many cards the player could get. We're going to assume we're not playing with the 5-card Charlie rule, which says that if you get to 5 cards, you automatically win. Most casinos don't do it that way, so we're not going to. But I think it's safe to say that you're never going to get more than 10 cards. So we're just going to say 10 in there. Again, if we were using an array list or if we were using a linked list, we wouldn't have to specify this, because we could just add and add and add, and it would just keep adding cards onto the end, and it would be no problem. It would handle that easily. But since we're going a little bit of a simpler route, we need to actually say how much, basically what this is telling me, Java, is how much of a memory block should we allocate. We know how much memory each card takes up, because we know what private data it has, i.e. a suit and a number. So we need to say how many consecutive blocks of memory do we need to allocate for this hand array. So that's why we need to do that. Okay, and of course it would be useful to keep track of the number of cards in the hand. Okay, so now let's make our constructor, and when we create a player, we would just basically want to give it a name. All right, and we're going to, when we create a player, we're going to initialize an empty hand. And the way we're going to do that is with a method, which we haven't yet made, called empty hand, which basically just empties out this hand. You know, when you first create, if we just, after this statement, the hand is by default empty. All the values of hand are null. But let's say that we dealt a hand, that we sort of played a game and we wanted to go back and play a new game. We would want to sort of, any cards that were in the hand from the previous game, we'd want to sort of zero out. So we're going to make a separate method to do this. So let's just make that right now, actually. All right, so we're just going through all the elements in our hand and setting it equal to zero, setting it equal to null, excuse me, and setting the number of cards to zero. Again, if you don't specify a value for num cards, it automatically defaults to zero. But this just ensures it's a little bit more clear. Okay, so now that we have that, let's make a method to add a card. Basically, we're going to deal a card to the player's hand. And we're going to make its return type Boolean, and you'll see why in a second. All right. So, in our return value is going to be a Boolean that describing whether the sum of the new hand is below or equal to 21. So whether we're still in the game, or if it returns false, that means that our sum is above 21 and we've busted. So this is just a check, right? But we would never want to add another card if we already have 10 cards. Oh, let's change that. If we already have 10 cards in our hand. Now, I don't think this should never happen, but you know, this is the kind of thing where you can't always control what's going on, how your player class is going to be used, and so let's just make a little check to make sure we don't accidentally add a card when we shouldn't be. Now, of course, you know, I'm sort of hard coding in the value 10 here, but we could just as easily make a little variable up here called maxnum cards that holds 10, and later we could change it to 5 or 15 or whatever. But just for simplicity, I'm just hard coding in 10 right now. So again, we're going to print a standard error. And now when you do that, I'm pretty sure what that does is it prints things in red and makes it clear that it's bad. So again, we're going to use the string formatting here. That's really handy. And notice the printf doesn't automatically print a new line, so that's why we print that new line right there at the end. Okay, so if we get into this inner part of the conditional, the program's going to exit. So if we get to here, then we know that we're good. Okay, so we're just going to say this dot hand equals our new card. and we're going to increment num cards by 1. Java's still complaining because it's saying, hey, you're not returning anything yet, so let's do that. So we're going to turn this dot get hand sum. Uh-oh, we haven't made that yet, but we will. You want to, hopefully the name shows you what it does, but basically we check to see whether the sum of your current hand is less than or equal to 21, and we return that Boolean value. Okay, so let's make this get hand sum method. Now, in theory, this should be very easy, right? We just go through and add up all the values, but there are a couple of things that make it not as easy. One, the way that we've represented card, you know, where the number, where this is a jack, this is a queen, 13 is a king, 1 is an ace, these aren't necessarily the values that these face cards and ace take in blackjack, right? Face cards take the value 10, and ace can take the value either 1 or 11. And so we need to sort of account for that in this method here. So let's make a few things that will be useful, a few variables that will be useful. So hand sum equals 0. And this is ultimately what we're going to return. So let's just do that right now. It's going to go down there. Okay. We're also going to create a variable called card num and num aces. All right. So we're going to loop through each card and calc each card's contribution to the hand sum. That's where that get number method that we, where is it? Right there, that we made, that's where it's coming in handy. All right, but we need to do a little bit of massaging to that. So if our card number is 1, right, i.e. if we have an ace, we're going to increment the number of aces we have, and we're going to add 11. You'll see what we're going to do with this in a second. Else if card num, if it's greater than 10, right, this means we have a face card, then we're going to hand sum plus equals 10. Otherwise, so basically if it's 2 through 9, that makes it really easy. Then we can just do hand sum plus equals card num. All right? Now, we need to figure out, if we're always adding 11, we could be busting, but so we want to turn this 11 into a 1 if necessary. So we're going to make a loop that says while we have aces and while our hand sum is above 21, we're going to subtract 10. Right? And this is basically going to convert those 11s into 1s for each ace as necessary. So while our hand sum is greater than 21 and the number of aces is greater than 0, we're going to subtract 10 from our hand sum, and we're going to decrement num aces. So as soon as either our hand sum goes below 21 or we have no more aces, this loop exits, and then we return the hand sum. All right. Finally, it's going to be useful to make a method to print out the hands in the player's card. The cards in the player's hand. And this will be useful from the gameplay standpoint. Then this show first card parameter says whether or not we want to actually print the value of the first card in the hand. For example, this is useful if we're printing out the hand of the dealer. We don't want the other users to be able to see the first card of the dealer necessarily, so we would say this is false. So if we're on the first card and we don't want to show the first card, then we print something like this. Otherwise, you just print the card. Okay, so that should, we got a problem here. That needs to be a comma. All right, so that should do it for our player class. And then the next step is to implement our, we're going to delete this, is to implement our game runner code. So let's first import our old friend, the scanner. All right, so now let's initialize that. And we're going to initialize our deck. And we're going to just, for this example, we're just going to initialize it with one deck of 52 cards. And we're going to say that we're going to shuffle it, passing it that true parameter. We now need to initialize the player objects. And one we're going to say is me. We pass it the name. Pass it Dross in my first name. And the other player is the dealer. And its name is just going to be dealer. All right, so now that we created that, as the gameplay starts with just dealing 2 cards to both the dealer and the player, i.e. me. So we're going to first add a card to our hand from the deck. And then we deal a card to the dealer. Good. And then we deal a card to us, and actually let's just copy this. Okay, so we've dealt 2 cards to me, to the player, and 2 cards to the dealer. And we're going to print the initial hands. And when we print our hand, we're going to reveal all that first card. But when we print the dealer's hand, we're not going to, because we don't want to see that. So we pass it the false parameter. And just print a few new lines here just for some formatting. Okay. So now let's create some variables that describe when both the me player and the dealer player are finished hitting. And we're also going to create a string answer, which we'll come to in a second. So now here's the main loop of the gameplay. We basically need to continue prompting the user, the human me, for whether or not we want to hit, and for the dealer, whether or not the dealer should hit. So while me done, basically, if me done is false, then basically while this whole thing is true, or while the dealer is not done, we're going to continue looping. And so let's start with, if me done is not true, then let's prompt us to either hit or to stay. Just print out a new line there for the sake of formatting. Okay. So now, if the player hits, we're going to use the string.compareTo, and we're going to ignore the case, so they can either enter uppercase S or uppercase H and S or lowercase h and s. So the way that the compareTo works is this whole thing equals 0 if they're the same. So basically, if the player wants to hit, then add the next card in the deck and store whether player is busted. So what we've done here is we're getting the next card from the top of the deck, we're adding it to this player, and if you recall, this add card method returns a Boolean value that is true when the total of the hand is less than or equal to 21. So if that is true, then when we not that, this whole value now becomes true when the hand is busted. And so we're done if we are busted, then we're done. Otherwise, so basically if the player said we want to stay, then we're also done. Okay, so now it's the dealer's turn. So our rule for when the dealer hits is if the dealer's value is less than 17, we hit. So pretty much the same thing as up here. And here what we're going to do is print the hand of the dealer. And actually, while I'm thinking about it, let's print the hand here as well. But it's going to be true. Okay, and we're just going to print out a new line here just for good measure to sort of make the formatting a little bit easier. So basically, we keep looping, prompting the player and the dealer to either hit or stay. Once both of them are done, basically once this is true and once this is true, both of these expressions become false, and therefore this whole expression here becomes false and the loop exits. So when the loop exits, we can close our scanner. And let's print the final hands. And here we actually will reveal what the dealer has and what we have. We're going to get the sum of both of our hands. Okay, and we win the game if my sum is greater than dealer sum, and my sum is still less than or equal to 21. Or if the dealer is busted, so if the dealer sum is greater than 21. And if that's not the case, then the dealer wins. Okay, so this, we just need to fix this. This is a dealer sum. Okay, so things look pretty good here, so let's test it out. All right, so here's our cards. So we have the 6 of hearts and the king of clubs, and the dealer has the ace of clubs. So let's hit. Okay, so the dealer has, whoop, that's not a problem. That's a problem. We don't want to see the dealer's hand there, so what's the problem here? Ah. Oh, I see what's happening here. So here are the dealer's cards. So we should not see this. So the dealer hits. Okay. Let's figure out the problem here. We shouldn't be able to see what this first card is. Up here it's hidden, but here somehow it's shown that it's the 3 of clubs. We don't want to be able to see that. So what we actually want if we go back to the player, we go to the print hand, show first card. Ah, here's the problem. It's not the dealer we want to print, it's me. That's the problem. All right, let's try that again. Okay, ace of clubs, 2 of spades. We definitely want to hit. All right, so now we have the ace, the 2, and the 4. The dealer stays. Okay, so let's hit again. So now we have the ace, the 2, the 4, and the 7. So if the ace is 11, then we're busted. So if the ace is 1, then we have 3, 7, 14. Let's hit again. So here we got the 10, that gives us 24, and the dealer has 19, so the dealer wins. Oh well, but looks like the gameplay seems to work reasonably well. Let's just play one more hand just to be sure. All right, so we have 2 7s. Now, if we were playing fancy blackjack, we could split these, but you're encouraged to implement that yourself if you like. We see the dealer has a jack, so let's hit. So we have the 7, and so we got an 8, which brings our total to 22, unfortunately. And the dealer has 2 face cards, and the dealer wins. So unfortunately, the dealer won both of those games, but it looks like our actual gameplay is working as expected. So that's all for today, and good luck in your future projects.